Hey everybody. So I'm going to go through a couple high-level details on how lights work, what type of lights we have, what type of settings exist within them. All of this is within HDRP, so we can dive into anything in depth if any of it sparks an interest with the group. So the main lights that we have in Unity are directional light, which usually comes by default inside of your scene. We also have a point light, a spotlight, and an area light. There are a few other things that we can get into at some point if relevant, but we have reflection probe, light probe, etc. So we can get into that if we need to. The first thing that I'm going to point out is a little bit more in the realm of post-processing, but it's helpful to understand for how your lights work. If you open up a new scene, which what we're looking at here is HDRP core, so it's not the template scene, but it does have HDRP built in. I've gone ahead and inside of the HDRP wizard that launches when you open HDRP core, I've turned on a few features within the DXR tab so that we can get into DirectX ray tracing if we want to. I'm going to close that out for now, but that's how you get into your wizard. Makes upgrading or migrating extremely easy. The reason why you see lighting already in the scene, even when we come in here and turn off our directional light, is because there are a bunch of settings that we don't immediately see inside of our inspector or our hierarchy tree that are impacting this project. So if we go to edit project settings, go inside of graphics into HDRP global settings, this is either already created for you or likely created in the HDRP wizard setup process. This is a default settings volume profile. So essentially what this is a fallback for any HDRP scene that's leveraging this to use all of these volume profile settings. The way that we override any of these is that you can do essentially three different things. One is you can create a whole new volume profile or delete this profile entirely, and then that causes other issues. The second one is that you can disable these items from this window within project settings. So if I wanted to turn off HDRI sky, you can now see what that looks like. If I turn off visual environment, you can see even more disabling. Usually the best way to do this though is to leave all of this turned on as a fallback so that you never inadvertently forget to have on your shadows or some exposure correction, etc. And instead correct it in the scene. So I'm going to right click, go into volume, global volume, create a new profile over here in the inspector, and then I can add an override here. So if I wanted to come into HDRI sky, I could actually turn this on and assign no cube map, and now it overrides my default settings. If I turn this back off, the default settings kick back in. That's how that all works. So I will leave that where it's at. Let's remove for now. To show the different lights, I'm just going to very briefly make a 3D environment, or scene rather. Duplicate this, swing it up, and let's get into ISO view. To get into ISO, I'm just clicking this middle cube over here, and then I want to duplicate again, spin it this way, and then get back into isometric and come drag it this way and this way. Okay, I'm happy enough with that. There are likely issues, but we'll move forward for the time being. So now I'm going to right click 3D object sphere just to pull a few items into here. 3D object cylinder. Okay, we'll drop that. Maybe we'll have that come up a little bit. And then last one will be maybe just a standard cube. Something like that, maybe. Okay. I'm going to move it all a little bit towards the corner here. So a directional light by default is already in your scene. The way that the directional light works is that by looking at this icon here, I can see this is the directional light, the sun, if you will, and these rays or lines that are coming out of it are the direction that the rays will be shining from. So if you're using a built-in physical sun and sky inside of Unity, an actual physical sun will be in the skybox up in that area in the sky that's driven by this light. We don't see that here because we're using the HDRI sky that we just looked at. That's all a predefined skybox. So if I move this, you can see shadows move with it. And the way that this works is that it has no fall off. It has no edge of the light. It shines indefinitely in all directions that align with the tangent of the icon. So if we're shining in the direction that we're looking here, if I look in tangent, everything up, left, down, and right of my camera is the plane that is being used to cast the light. So that is how a directional light works. Usually you only want one in a scene. Rarely I would use more than one for many reasons, but one of which is just that only one directional light is used for most of the light baking data that's gotten inside of Unity. So it doesn't really help you to have the overhead of multiple directional lights. It also gets a little bit tricky if you want a directional light and you want items moving, but you want their shadows to be dynamic. Now you have a light that's shining on everything in real time with shadows updating in real time, and it's just a lot of overhead. So usually one directional light is the rule. Angular diameter, each of these things you can kind of come in here and highlight and just understand what they're doing in here with the tooltips. For all intents and purposes today, that essentially impacts the shadows that we're looking at. There's a lot more to it, but that's the high level. Celestial body we won't worry about, but this is the idea of how this all looks in the sky and how it impacts the size from the sky. Emission is the main one that we'll use in all four of these lights. You have color or filter and temperature. So color, you can get extremely aggressive and usually hit things that are not quite realistic. Filter and temperature, try to limit everything into a generally realistic level of hue difference. So you can get very blue, very orange, but that's about the depth of it with the temperature. And of course you can apply a filter. For right now, I'm just going to lean that a little bit towards sun color. There are a few other things that we can get into here, but for now we'll leave that where it's at. We do have volumetrics turned on with this. You'll notice though we don't really see any volumetrics, and we'll get into that right now. So if I put in a spotlight, we're going to skip point for the time being. This spotlight is right up here. And one thing that I think I want to do is probably pull the intensity down of my main light. And I also think I want to, I may live to regret this, but let's see. I'm going to add an override and override the visual environment with no sky. Just for now, so that I can really focus on what we're looking at. Now I'm going to pull this light down even further. We're getting some effects that you can see, like the bloom that's coming in by default in the background. So you know what, just for the sake of this demo, I'm going to turn off all of that stuff. So if I turn off my directional light now, all that we see that's lighting the scene is my spotlight. Now we talked about volumetrics, so let me get into that. If we go to global volume and I add a fog override, fog is the key setting that allows you to really visualize volumetrics. So if I come in here and I turn on volumetric fog, you can now see that that is updating. I also want to update the quality so that it looks a little bit more crisp at the edges. So this is a cool way to visualize what your lights are doing. It also just looks cool. I think everybody likes God rays, right? Okay, so you can start to see how that looks. The settings of a spotlight are outer angle, where we can get much wider. Inner angle lets you essentially control the drop off. So if you go all the way out, you have a very intense drop off. Radius gives you some more control here. And then we have our ability to control filter, temperature, color. So I'm going to change this to color and do something kind of extreme. And probably dial this down just a little bit. Within here, there are other settings that we can get into. One of which that I'll show just because it's of interest is if I do a spotlight and I come down here close to something, I can now, with a cookie, essentially put a filter or a screen on the end of my light, if you will, and create a projection. Now the cool thing here is that this does work with volumetrics. So the one that is now the cookie that is filtering where the light can shine from the spotlight actually controls how the fog is impacting the light. So it's not just a hokey magic trick. It's genuinely impacting how the light projects, which is pretty cool. I'll take the cookie off. The other setting that you can get into here is IES, which IES profiles are essentially agreed upon standards for how the light will generally fall off, meaning you can take physical lights, calculate what the IES profile would be given many factors, and then replicate that as closely as possible in a virtual world that we're working in now. That's where you would get your IES profile and plug it in here is to try to match a specific light or a specific bulb. Then we have volumetric, so I can multiply this if we want to get more intense with it. Also, if we want to cast shadows, I can turn that on, change the near plane. You can see as I get beneath here, it's going to allow the shadows to go. So I'm just going to pull the near plane up above the ground. And I will probably go ahead and delete this light. So that's as far as we care about within spotlights. Then we're going to create a point light. And this point light immediately is illuminating our whole environment. So let's put this kind of back in the corner. And I want to do a couple things immediately, but I do want to point out that you don't have to adjust all of your settings over here. In the inspector, a lot of them have handles that you can pull in. So you can see that my range is modifying over there in the inspector as I pull in my overall range. So I'm happy with that-ish. Maybe I'll change this to something that's kind of wild as well. So I'll go to color, do a bright blue, pull this down maybe. Probably pull the intensity down even further. Volumetrics are enabled, though not the most visible with a point light. Certainly the spotlight is the place to be. Let me pull the outer angle down. So you can see the volumetric is still happening here with the red. As the outer angle expands, it gets a little bit harder to see, but you can see it right there. With a point light, you essentially have one point of emission of the light. You can increase, decrease the radius. All of your emission settings are in here, the same as the others. And volumetrics, again, we have on. We're not going to mess with a shadow map. So point lights are relatively straightforward. The last thing I want to do is show an area light, which an area light in general is meant to emulate like a TV screen, a computer monitor, a window that's shining light into your scene, something of that nature. And you can do a rectangle, a tube, or a disc. So let's just assume that this wall over here is casting this light. So I'm going to use these handles. All right. So I'm going to turn this to green. And I'm going to turn the intensity down a good bit. And you can see that this is essentially casting in one direction as I indicate. If I change it over to tube or disc, it changes slightly. One is real-time only, one is baked only. We'll talk about in just a moment. But that's in general what an area light is used for, is that you need to essentially achieve the effect of a shape of light emitting light. Only other thing I'm going to go into, because these are relatively all of the same settings, is that with a spotlight, similarly to an area light, you can also change the shape from cone to pyramid to box. With volumetrics turned on, you can really tell what each of those is doing, so I won't dive too deep into that with the amount of time that we have, trying to keep this under 20 minutes-ish. Let's see, only other thing that I want to do is change these lights into something a bit more efficient, which could be a baked light. So we're going to make these all baked, meaning I have to bake a light map. The other piece of a baked light that is important is that each item in a scene to receive baked lighting needs to be, at minimum, GI static, meaning global illumination static, if you're going to bake GI, which I plan to. So I'm going to turn all of this to contribute GI. Since none of it is moving, we can also just set it all to fully static, which I'm fine with as well. Now when I bake, it will actually impact all of these. Something else that I might do just to have some fun with it would be to create a material. I'm going to name this Light Up Matte. And I'm going to drag this onto our sphere. And I want to give this an emissive intensity. And we'll just call it something like that. So I'm just going to pull this up a little bit. We will see what happens. Usually with an emissive material, actually always with an emissive material, I'll need to bake to kind of see what's happening, but hopefully that will be of interest when we get to that point in our process. So at this point, I have one emissive material, I have one area light, I have one spotlight, I have one point light, and we've hidden our directional light for the time being. I'm going to leave the directional light hidden because I don't really want it impacting the scene right now. And now we can come up into our lighting. And I'm going to create new light settings just to make sure that we're working off of this. So I'm going to call it Work in Progress Lights for this tutorial. We do want baked global illumination on. However, I want to change that over to baked indirect. Again, there's a lot of detail we could get into here, but for all intents and purposes in this workflow, just stick with baked indirect for now. I'm going to switch this over to GPU baking since I have a beefier GPU than CPU. Maybe I'll up the light bounce a little bit. I'll keep everything else where it's at for now. And if I generate lighting, what we should see is GI baking out and making this look more realistic than it currently is. So let's hit generate lighting, see what it looks like, and we'll keep an eye out for this. Okay. So everything looks pretty good. The emissive material is the only one that's acting a little bit strange. All right, so I'm looking around settings right now. I can use emission intensity, or I can turn it off. I don't suppose that matters a ton. Emission multiplied with base. My base map is kind of irrelevant, but let's set that over here to a yellow. And for GI, which says none right now, could be the issue, I'm going to go with baked. Let's go back into lighting, generate lighting, and see what happens. Okay, something is happening. I'm a fan. I'm going to go ahead and go back into intensity and tone this down to 100. Pre-bake. There we go. Looking a lot better. Okay, so now I'm going to pull this down to 10 nits and bake. One last thing that I wanted to cover that I didn't quite get into well enough from my perspective in this is the idea of real-time lights. So if I go into my gizmos, pull up Spotlight, I just kind of switched all of these over to baked without talking too much to y'all about it. In a nutshell, the way that real-time versus mixed versus baked works is that real-time is real-time direct and real-time indirect lighting, meaning your light comes into the scene, it hits a surface, that's real-time. It bounces off of that surface and lights up the rest of the environment, that's also real-time. Mixed is your light comes in and hits a surface, that's real-time. It bounces off and hits other surfaces, that is baked. So your indirect lighting will be baked using mixed. And then baked is ratcheted all the way forward, where if you have a light, it hits a surface, that is baked, and then it's indirect where it bounces off and lights up the rest of the environment is also baked. So that's your 3 different lighting modes in a nutshell. Okay. So that's a pretty quick overview of what we're looking at with lighting. Again, we did directional, area, spot, and point, as well as what an emissive material is and how to get that showing up. Inside of a scene where we also discussed global volume overrides and how each of the project settings have their own default post-processing effects that it will fall back onto. Hope that was helpful. Let me know if y'all have any questions to follow up on this. See ya.